Hi, I'm Saeed Bilal Rizwan, a master's student in data science from IBA, and I would like to present my project in machine learning 2. The project is basically about comparing different dimensionality reduction techniques and its effect on machine learning performance. So how I went about it is I took 15 datasets from UCI repository. 8 of them were classification datasets mentioned below, and 7 of them are regression datasets. So I have broken down the project into two parts, classification and regression, and that's how I went about it. And the techniques that were chosen were the linear uh, dimensionality reduction techniques, such as PCA and LDA, SVD. So PCA also, there were a few other variants of PCA that were tried as well. So the goal of the entire linear dimensionality reduction techniques is to map the dataset into a lower dimensional space. And let's talk about the methodology. So firstly, in the first part, I did pre-processing of each data set. So it was a standard pre-processing that the unnecessary columns were removed, the data types and were changed, and the missing values were addressed. Similarly, the categorical variables were all one-hot encoded, and all of the numerical variables were scaled using a min-max scaler. So all that's for all of the datasets for regression as well as classification. Then came the machine learning with dimensionality reduction part. So I actually developed an entire pipeline for this, and I would take you through the code step by step. Let me just show you the pipeline as well here. So yeah, so this is the pipeline. So initially I used a lazy regressor or lazy classifier. So these are basically lazy predict library, which is a very cool library which lets you run all the classification algorithms and all the regression algorithms just by just using a few lines of code. So I utilized that, and what I did was that firstly I developed this pipeline. So the inputs of the pipeline is just the training set and the testing set, and the output is the results of all the algorithms and of all the methods applied to it. So how the pipeline works is, first it takes the training and testing set, and it runs the lazy classifier to run all the algorithms on it on the original data set without any feature reduction. Then onwards, it applies PCA to it here, and then it runs lazy predict on the resulting data sets. Similarly, when it goes for incremental PCA, same for the sparse PCA, and then it applies LDA, linear discriminant analysis, and it also runs lazy predict on it. Lastly, it runs a singular value decomposition on it, and then it runs lazy predict on it. Finally, it compiles all of the models together, all of the results together, and give it in a very neat fashion. So that's the pipeline that I developed. And let's just see one of them in the works as well. Pick one marketing datasets from the classification datasets and see how it works. So I firstly use train test split to actually split the dataset into 0.3 ratio, 0.25 ratio actually. And then I ran the pipeline. Look how it runs, look like in a very neat fashion. And then finally it outputs a result in this way. So it is very easy to compare now between you have all the metrics here: accuracy, ROC, F1 score, and you have all these algorithms, so you can pick any algorithm and compare using any metric you like. And these are all the without DR, with PCA, using incremental PCA, LDA and SVD. So that's what I did for all of the datasets, for all the classification datasets. The similar pipeline was developed for the regression datasets as well. And firstly, the regression datasets for pre-process, and this pipeline was developed. It is exactly the same pipeline, but the only difference is that the LDA is not applied here, because LDA is only applicable for classification datasets. So that's why I did not use LDA here. So similarly, it runs in the similar fashion, and finally it outputs the result. Then all of the results were compiled in a notebook. Let's just say the classification datasets, and you can see here all of the results are here, and an analysis table was developed as well for all of these. And you can see here, let's just go to the graphs, and you can compare the F1 score of the marketing dataset, and you can just let's just pick XGB classifier and see how it works. And you can see that without DR has the highest F1 score, but very similar is the PCA, which is like just 0.01 difference, which is a very minute difference, but I'm sure it reduced dimensions very, very quickly. And we can concur from here as well. Like, look, the dimensions without DR were 35, and then we reduced it to 18. And the best technique, in my opinion, here was the LDA because it reduces dimensions to 1, although it does not compromise a lot on the variance capture here as well. Like, let's just pick the XGB classifier and see the R accuracy, and you can see it is 0.87, and with after applying LDA it's 0.85, around 0.86. So it is very, very good, and it reduces the dimensions. Is the hard dimensionality reduction technique, so it is one of my favorites, and I have made sure that it is out there in my blog as well, that LDA is one of the best techniques to actually go for. So initially when you're classifying, go for the LDA, and if like you see a very huge drop in performance, then you go for PCA or SVD, singular value decomposition. So like for more information, you can actually read my blog here. So this is my blog, and you can see that I have written a very detailed blog on Medium. So you should really spend your time here and actually read it properly. So I hope you like my project, and this was me. Take care.